Bismillah ar-Rahman ar-Rahim, my dear students. Here is your mathematics teacher Muhammad Amjad Saeed from Pakistan International School, Taif, Saudi Arabia. Today we will continue our lecture number 47, chapter number 11 from 10th class. Here is exercise 11.1. According to your revised reduced syllabus, we have question number 1 and 2 of your exercise 11.1. So we have the question: in a circle, two equal diameters AB and CD. Question number 1: in a circle, two equal diameters AB and CD. Two equal diameters AB and CD intersect each other, then we have to prove that actually in two equal diameters AB and CD, AB and CD intersect each other, then AD is equal to BC. Measurement AD is equal to measurement BC. Dear students, we have three possibilities in such a way. This is, instead of equal diameters, these are equal chords. In a circle, two equal chords AB and CD intersect each other, then AD is equal to BC. Dear students, we have three possibilities like that. Here is one circle, second and third. Center is O. Two equal chords AB and CD. The possibility is that this one, maybe these chords are in less than semicircle portion. Here is equal to semicircle portion, and these chords may be greater than semicircle portion. There are three possibilities. In a circle, two equal chords AB and CD intersect each other. So there are AB and CD. Here is AB, CD, then AB and CD, and AB and CD. These are three possibilities for two equal chords AB and CD. Maybe they are in less than semicircle portion, they are equal to semicircle portion, and they are greater than semicircle portion. Semicircle portion means the diameter passing through the center. This divides the circle into two half circles, and half circle is also known as semicircle. So here we can have what is given in a circle with center at O. AB is congruent to CD. AB is congruent to CD. To prove this, AD is congruent to BC. To prove is AB is congruent to BC, what is construction? This is AB congruent to BC. What is construction? Construction is join O to join A to C, this one, and join A to D and B to C. In all cases, join A to C, B to C, and D to A. Join A to C, B to C, and A to D. Dear students, join A to C, B to C, A to D. A to C, B to C, and A to D. We have three possibilities. Now, what is proof? Proof is statements and reasons. Dear students, we have one triangle ABC and other triangle is ABC. For example, this is triangle ABC and the second one triangle is ADC. In all cases, ABC, then ADC, like this. Dear students, we have given in a circle with center at O, two chords are congruent AB and CD, AB and CD, and AB and CD. To prove is AB is congruent to BC, AD is congruent to BC, AD is congruent to BC. Join O to C, A to D, and B to C. Similarly, join B to C and A to D. Here, B to C and A to D. And join A to C in all cases. Actually, that was not given because given was AB and CD only. So join A to C is in all cases, B to C in all cases, and A to D in all cases. Dear students, this line must be the dotted one also. In the correspondence of triangle ABC and triangle ADC, AB is congruent to DC, AB is congruent to DC or CD, this is given. Then AC is congruent to AC, common in both triangles, and angle ABC and ADC. Angle ABC is congruent to angle ADC. Angle ABC is congruent to angle ADC. Angles on the same side of triangle. Angles on same side of triangle. Basically, you have seen this theorem in chapter number 16, ninth class. Two triangles with same base and equal altitude, they will have equal areas. They will be congruent. They will have equal areas. That is your chapter number 16, ninth class, theorem number 16.3. You can check from ninth class level. I hope that you understood up to here. Dear students, after that we have, therefore, triangle ABC is congruent to triangle ADC. You can have side-side angle postulate. If the two triangles are congruent, then their corresponding sides are also congruent. So AD is congruent to BC. Corresponding sides of congruent triangles. Dear students, that was your question number 1 in exercise 11.1. So we will have question number 2 also in exercise 11.1. According to your reduced syllabus, after that inshallah we will have our theorems of chapter number 12, and there are 2 theorems of chapter number 12, and then review exercise. And we will move to our last chapter, chapter number 13. Here is 11.1, question number 1. That was your question number 1. I hope that you understood this question. Dear students, keep on revising your syllabus at home. Even after completion of your syllabus, you must revise properly of your questions and MCQs part so that you can have better idea for the annual examination. After that we have question number 2 of your exercise 11.1. In a circle, prove that the arcs between the two parallel we have yes 11.1. In a circle, prove that the arcs between two parallel and equal chords are equal. The question is, question number 2. In a circle, prove that the arcs between two parallel and congruent chords congruent or equal chords are equal. What is the nature of the question? You must understand first of all. Remember that here is, in a circle, prove that the arcs. In a circle, prove that the arcs between two parallel and congruent chords. Up to here, this is given. Here is the circle. Here is the circle. These are two parallel and congruent or equal chords. Circle with center at O, AB and CD are two equal and congruent chords. The relating arcs, this is the relating arc. This is the relating arc. This one. So AB is congruent to CD. This arc, these two arcs will be congruent. We have to prove it. So again, in a circle with center at O, the two chords AB and CD are parallel and equal. Then to prove is arc AB is congruent to arc CD. This is to prove. What is given? A circle with center at O, with center at O, two chords AB and CD are equal and parallel. That is, AB is congruent to CD. A circle with center at O, two chords AB and CD are equal and parallel. That is, AB is equal to CD. They are given. To prove is, we have to prove that arc AB is congruent to arc CD. Arc AB is congruent to arc CD. Join O to A, O to D, O to C and O to B. Join O to A and O to D, O to C and O to B. Construction is join O to A, O to D, O to C and O to B. Dear students, 1 and 2, label the angles 1 and angle 2 as in the figure. Now proof. Statements and reasons. In the correspondence of triangle OAB and OCD. In the correspondence of triangle OAB and triangle OCD. Yes, OAB and OCD. OA is congruent to OD. OA is congruent to OD. Radii of same circle. Radii of same circle. And OB is congruent to OC. Radii of same circle. AB is congruent to CD. This is given. Dear students, OA is congruent to OD, radii of same circle, OB congruent to OC, radii of same circle, and AB is congruent to CD. these two chords are congruent, this is given. So after that, therefore, triangle AOB is congruent to triangle COD. What is that? Side, side, side postulate. Side, side postulate, this is your reason. Hence, angle 1 is congruent to angle 2. Corresponding angles of congruent triangles. Angle 1 is congruent to angle 2, corresponding angles of congruent triangles. And remember that equal angle at the center will have equal arcs. So this is the reason. Now therefore AB is congruent to arc CD. So arc AB is congruent to arc CD. What is the reason? Arcs corresponding to equal angles are equal. Arcs corresponding to equal angles are equal. This is the reason for AB arc is congruent to CD arc. Dear students, after that we have chapter number 11, miscellaneous exercise chapter number 11. And we have MCQs. This is given in your syllabus, in revised reduced syllabus. So we will discuss miscellaneous exercise 11 and multiple choice questions. Dear students, we have a 4 centimeter long chord. Subtend the central angle of 60 degree. Then the radial segment of this circle is 4 centimeter. Here is the concept of, in fact, this is the concept of radian measure of angles. Concept of radian measure of angles. We have that. And what is meant by radian angle? The angle subtended by the arc at the center such that the length of arc is equal to radius of the circle. That angle subtended at the center is known as 1 radian. Dear students, actually 1 radian, we have seen this in chapter number 7. 1 radian is equal to 180 over pi degrees. And approximately this is 60 degree angle. 1 radian is equal to 180 over pi degrees, that is 57.3. Actual value is 57.3. So this is according to definition of radian, that if length of arc is equal to radius of the circle, then its corresponding angle will be 1 radian, that is approximately 60 degree at the center. So that's why when someone says that if the angle is 60 degree at the center and arc length is 4, then radius will be 4. And if radius is 4, arc length will be 4. So this is the reason how you will get, basically, this is the circle, this is length of arc. If arc, this length of arc is equal to radius of circle, then the center will be equal to 1 radian, which is approximately equal to 60 degree. So that's why your correct option is 4 centimeter. After that, the number 2. The length of chord and radial segment of circle are congruent. The length of arc and radial segments of center are congruent. Then the angle subtended will be equal to 60 degree. This is your C option, which is correct. After that, number 3. Out of 2 congruent circles, arcs of circles, if one arc makes an angle of 30 degree, then the other arc will also make the angle of 30 degree. Definitely, if the arcs are congruent, their central angles are also congruent. Last question we have seen that. And after that, an arc subtends 40 degree at the center, its corresponding chord will also make. Basically, look at that. The question is, this is the arc which is making the angle center 60 degree. If you draw this line, this is known as chord. So if the angle subtended by arc is 60 degree, then angle subtended by chord is also 60 degree at the center. So your correct option is B. Pair of chords of circle subtending 2 common central angles, they are congruent. Definitely, if the central angles are congruent, for example, here and here, central angles are congruent, then these arcs will be congruent, and even these chords also will be congruent. This was your correct option A. Point number 6. If an arc of circle subtends the central angle of 60 degree, then the corresponding chord will also make. If arc is making at the center 60 degree, then corresponding chord is this one, straight line. This also makes the angle of 60 degree. Correct option is C. The semi-circumference and the diameter of circle both subtend the central angle of, what is semi-circle? Look at that. This is the center. The diameter passing through the center. This portion is known as semi-circumference or semicircle. Semi-circumference or semicircle or the diameter of circle makes the central angle is equal to 180 degree. So your correct option is 180 degree. That is your point number B correct. The chord length of the circle subtending the central angle of 180 degree, they are always double of the radial segments. Definitely, this is the chord which is making 180 degree. This will be the double of radius, that becomes diameter. Your correct option is C. Point number 9. If a chord of circle subtends the central angle of 60 degree, then the length of chord and radial segment both will be same. They are congruent. 2 arcs opposite to incongruent central angles. 2 arcs opposite to incongruent central angle. For example, this angle is greater. Definitely, this one is greater, smaller. If the 2 arcs, the arcs opposite to incongruent central angle will also be incongruent. They will be different in length. So your correct option is B option. So dear students, that was your review exercise 11. Miscellaneous exercise 11 and 11.1 exercise. Now we are moving to our chapter number 12, theorem number 1. Chapter number 12. Theorem number 1. Be careful about the MCQs. They are technical and they are conceptual in chapter number 11 and 12. So be careful about the definitions, The concepts of chord, segment, chord, diameter, central angle, circumangle, etc. Here is chapter number 12. Theorem number 12.1. What is the statement of the theorem? Statement of theorem is the measure of central angle of minor arc of a circle, the measurement of central angle of minor arc of a circle is double the measurement of central angle of the minor arc of the circle is double that the angle measured subtended by the corresponding major arc, double than the angle subtended by major arc. Here is the circle with center at O. This is AB. This is known as minor arc. And this arc is known as major arc. Suppose this is C. This is minor arc. Minor arc is basically the arc subtended at the center less than 180 degree. Any arc which is making the angle at the center less than 180 degree, that is minor arc. Or on the other hand, you can say minor arc will be less than half of semicircle portion. So AB is minor arc and ACB is major arc. The question is, angle subtended by minor arc at the center, this is known as central angle, it is double than the angle subtended by major arc, that is ACB. We have to prove that angle AOB is equal to 2 into angle ACB. Angle, central angle of minor arc is double than the circumangle of the corresponding major arc. So what is given? The given is a circle with center at O, circle with center at O, AB is the minor arc. AB is the minor arc. Angle AOB is central angle, while angle ACB is circumangle. What is given? A circle with center at O. AB is the minor arc. Angle AOB is the central angle and angle ACB is the circumangle. To prove is angle AOB is equal to 2 into angle ACB. Angle AOB is equal to 2 into angle ACB. that we have construction. Draw diameter CD and name the angles as 1, 2, 3, 4, 5 and 6. Construction is draw diameter CD and label the angles as in the figure. Label the angles as in the figure. Now proof is and statements and this is reasons. Now in triangle OAC, in triangle OAC, OA is congruent to OC. OA is congruent to OC. OA is congruent to OC, radii of same circle. Radii of same circle. If OA is congruent to OC, it means that angle 4 is equal to 6. Therefore, angle 4 is equal to angle 6. If two sides of triangle are congruent, their opposite angles are also congruent. If two sides of a triangle are congruent, their opposite angles are also congruent. So you can say that angle 4 is equal to 6. 4 is equal to 6. But angle 1 is equal to angle 4 plus 6. This is well-known theorem. I think it is mentioned in class 8 even. In a triangle, exterior angle is greater than opposite non-adjacent interior angles. In triangle OAC, angle 1 is exterior angle and angle 4 is non-adjacent opposite interior angle. So angle 1 is equal to 4 plus 6. Actually 1 is greater than 4. But 1 is equal to 4 plus 6. This is the corollary. So here you can have angle 1 is equal to angle 4 plus angle 4. Because angle 6 is equal to 4. We have proved that. Hence, angle 1 is equal to 2 into angle 4. Angle 1 is equal to angle 2 into angle 4. Similarly, angle 2 is equal to 2 into angle 3. Similarly, 2 is equal to 3 plus 5. But angle 3 is equal to 5. Therefore, instead of 5, we will apply 3. So angle 2 is equal to 3 plus 3. So angle 2 is equal to angle 2 into 3. Adding them, what will be? Angle 1 plus 2 is equal to 2 into 4 plus 2 into 3. Take 2 common, angle 4 plus angle 3. Dear students, what is the angle 1 plus 2? This one. Angle 1 plus 2 is equal to angle AOB. And this is 2 into angle 4 plus 3 is angle ACB. Therefore, this is angle ACB. Dear students, what was to prove? That was angle AOB 2 into angle ACB, angle AOB 2 into angle ACB. So that was your theorem of your chapter number 12. That is theorem number 1. I hope that you understood this question and theorem also, and you can revise at home. Okay, Allah Hafiz and Assalamu alaikum wa rahmatullahi wa barakatuh.